Hello, this is Denton Yoder, instructor for BSE-2304, the Biological Systems Engineering CAD class. Today's lab is about script files and how you can use them manually or programmatically to draw things in AutoCAD. The first example we're going to work with is a point file. A script is anything that you could type at the keyboard in AutoCAD, but it's stored in a file with a .scr description or extension on the end of it to notify the machine that it's a script. We can turn a file into a script just by renaming it and taking the previous extension and making it a new one. I'm going to copy this point file. Give me a copy, right click, paste. And I'm going to call it output. Hello, back up. Output.csv. CSV files by default open with Excel. If I double click the output CSV, it opens up in Excel. If I right click on it, I can choose to open it with something else. I'm going to use Notepad++, or you could even use just plain old Notepad if you wanted to. And it says, oh, I can open that file as well. Opening it with Excel gives us an easy way to edit the file columns. So if I look at the file, I've got a point number, point ID, east, north, elevation, code, date, class. If I delete off the code, date, class and delete off the point number and point ID, I'm left with easting, northing, elevation, which to me means X, Y, Z. I'm going to save this file, and it says, do you want to keep it as a CSV? Yes. Now close it. I just did save it. I'm not going to save it again. Now the output CSV file, if I open it in something else, is obviously just 3 different points with commas between them. I'm going to remove the first line and put in the command point. Now if I switch over to AutoCAD and I type in the command point, it'll insert a point in the drawing. It's not real exciting, but that's what it does. If I put a prefix on that command, multiple point, I can get it to do several points at the same time. Escape to get out, PD mode, something like a 34, and I can see those points. Okay, so the prefix multiple will make the point command keep repeating. Back to my text file. In front of the word point, I'm going to put multiple space point. The point command requires an XY or an XYZ. The file is going to provide those, and the command will repeat, and the length of this file looks like 569 lines. So that's going to be a lot of points. Save this file. One other change I need to do to the file is it is now a CSV, which AutoCAD doesn't care about. If I change it to an SCR, yes, I want to change it. It is still, if I open it in Notepad++, the same file, I just changed the name. You do want to note that changing a name does absolutely nothing to the data inside a file. What it does in this case, though, is it changes the functionality of another program like AutoCAD. When it sees an SCR, it tries to type it in at the keyboard. So, for example, if it sees a CSV, Excel will try to open it. So I'm going to take the output file, drag it to AutoCAD. escape to get out of the command, zoom extents, zoom in a bit here, RE for regen, and I've got a bunch of cross sections on Strubles Creek. If I do a PD size of maybe 0.25, it looks a little better. So I was able to make a drawing with points in it. I entered over 500 lines of data in a second by putting the command multiple point in front of it, making it an SCR, and dragging it into AutoCAD. Now in class, you can slap a layout on that, put a border, title block, rotate it so it fits the screen good, make sure you have a north arrow and a graphic scale, and you have a drawing. All right, you'll need to save yours and submit it. I'm going to just X out of mine. Okay. Start another new drawing. So what we saw is that we can make a script file, and that script file can do work for us. Another thing we can do is programmatically generate a script file. I have another text file called football text. Football text is actually a program. It's about a page long. It's a subroutine called Save Football, and it ends down at the bottom. This program defines a variable F file name, and it has a function to save the application, and that file name is put into a system object, and it writes data to it. So it's going to write turn snaps off, write layer make football lines, color 3, write a line, here, 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 close, make a loop, drawing the yard lines, make another loop, drawing the 1 yard ticks, make a layer for text, another loop, putting the text in. So I'm going to copy this to the clipboard. And we're going to use Excel. Now, I probably should be using Python or R or some MATLAB or something fancy, but I just want to show you that everybody typically has Office 2016 or newer, and what I can do in Office is I can do developer tools or programming. Now, I don't see it on the menu, but if I hold down alternate and hit function key 11, I get the Visual Basic for Applications program. Now, if you want to see it on the menu, it's easy to get. The file pull down has an options, and under the customize ribbon is a checkbox for turning on developer mode. Developer mode gives you a ribbon menu, and the first item on it is Visual Basic. You also can use that to record and play macros and things like that. What I'm going to do is add or insert a module and paste in the code I just did from that file. So I have my subroutine to draw a football field. The way you run one of these modules is back in Excel. You can say execute macro and run it by name, or if I'm in VBA, the Visual Basic Applications window, I can click anywhere inside the subroutine, as long as I'm not clicking the pause button on a line, but just click in the text area and hit the green arrow for run, and it says, hey, I want to save a file. Okay, how about Documents 2018? We'll call it football. And I can now close out. And no, I don't want to save anything. But if I go to my Documents folder, 2018, drag football script to my drawing, zoom extents, Zoom extents, I get my football field. So I was able to draw a football field just by writing a program to draw the lines. Now, you'll get to turn that into a drawing and submit it as homework. I'm just going to close it. I'm going to start another new drawing. Start a new drawing. I'm going to show you one more example, and that is the sphere drawing. You can do the chart drawing on your own. The sphere drawing is almost identical. It just has one extra step. So back in my, let's go to desktop and go to new class, lab 4, sphere text. It's 2 subroutines. I'm going to grab them both, copy to the clipboard, fire up Excel, and then I'm going to Developer, Visual Basic, insert a module, paste. Now in both the chart and the sphere, it's 2 steps. Step 1 is to run the top script, or the top subroutine, which is going to do a matrix of values into a spreadsheet. When I run that, if I minimize the VBA, you'll see I now have a spreadsheet with a couple hundred lines of data. And I've got 5 fields of data. Now my second macro is going to read the 5 fields of data and use the first 3 for X, Y, Z, and then I'll use the fourth field for the size of the sphere and the 5th field for the color of the object. So if I go back to VBA, the second program looks a lot like the last one we did. It makes a file system object, it saves a file, turns snap off, sets a layer for the spheres. Looks like it uses color 1 red for the layer. It really doesn't matter because it's using cell 1, 2, and 3 for the XYZ, and then it's using cell 4 for the diameter and dividing it by 2 because it's going to ask for radius when you draw a sphere. And then it's going to set the color and draw the sphere. And the color was based on cell 5. It's going to do all this stuff. Clicking anywhere in this subroutine and running it will actually ask me to save this stuff. I'm going to put it in 2018, and I'm going to name it Sphere. Now I can close this out, No, I don't want to save it. If I go to my documents, 2018, I now have a sphere script. Drop it in my drawing. Zoom extents. I have spheres. Now I use a color toolbar, the visual styles toolbar. I love that. I also like the 3D navigation toolbar to let me move that around at a different angle. In the 3D navigation, you can turn on other things like make it a perspective view instead of a orthogonal view. And you can, if you want, do a free orbit and a continuous orbit if you just want to spin it and let it go. You also can turn on visual aids if you want to show a compass. A compass lets you see where XYZ is at on the screen. You don't have to make it spin. You can just rotate it to where you want, do a capture or a print from this space, and put this in your data chart. What you just did is you graphed 5 axes of data by graphing a location X, Y, Z, a size or diameter of the sphere, and a color. All right, the chart is really the same thing. You run the first module to populate your spreadsheet, run your second module to draw a chart. All right, thank you much. Enjoy the lab. Ta-ta for now.